Good afternoon, good evening. This is Paul Watson from Oninit. This afternoon or this evening, we're going to be chatting about enterprise replication. So we'll just crack on and we'll see how far we get. The guidelines here, this webcast is being pre-recorded. You can download the slides at a later date from the IIUG. If you wouldn't mind muting your line so we don't get any background noise. And if you want to ask any questions, just press the chat button and hopefully somebody will see it and we'll be able to catch you and catch up any questions. So let's get on with it. So Paul Watson, I've been doing Informix now for a little over 31, 32 years. I founded Oninit back in 1999-ish. I've been based in the US now for a little over 16 years. And most of the time I specialize in either ER work or TimeSeries work. So what we're going to do is today, we're going to cover ER. This is not obviously comprehensive. A comprehensive ER course 3 or 4 days, which we could obviously arrange at a later date if that's what some of you want. So what we're trying to do is just cover the basics. I amused myself when I was looking at this presentation, starting to activate, and realized that most of the commands I would use on a day-to-day basis, the ones we're going to touch on, I don't actually know them because everything I do is heavily scripted. And I would recommend if you go down an ER route, you spend some time generating some scripts. At a pure personal level, I prefer ER over HDR, although HDR is slightly, well, is simpler to set up. I think ER gives you much more flexibility. It just comes a little bit of an effort of configuration, but that flexibility is well worth the effort. So what we're going to cover is a basic overview of ER. We'll look at some simple configurations, a couple of simple examples, and a couple of neat tricks that will save you a lot of time and hassle and pain, and probably an awful lot of consulting hours from other people like myself. So what is ER? So ER is replication. It uses asynchronous data replication to update the database that resides at a replicated site after the primary database has committed the change. The key there is it's asynchronous and it happens after the change. Now with async replication, the delay to update the replicated site database can vary depending on the business application and obviously the user requirements. However, the data will always eventually synchronize to the same values on all sites. The major benefit of this type of data replication is that if a particular database server fails, the replication process can continue and all the transactions will still be played on the source, and they will be spooled or kept for later application to the target systems. When ER comes back up, as if by magic, it will just reconnect and everything will just be up and running in a manner very similar to HDR. Enterprise replication is log-based, so it uses a process called Snoopy that monitors the logical logs. It reads the logical logs, interprets them, and pushes that information out over a series of queues to the target tables, where they're evaluated and applied to actual rows. The other thing about ER, it's an incredibly flexible architecture. Unlike HDR, you can replicate individual tables, individual databases, a subset of a table, i.e. not all the rows, or a subset of the columns, i.e. not all the columns. You can update either direction. You can have multiple servers in there, basically as many as you would like, up to hard limit within the system. So general topologies that we tend to talk about. If you notice those images, I'll admit they were stolen from IBM as a slide deck from a long time ago. To support a primary target replication, where primary target replication is, we've got a master server where one server is responsible for all the changes, as we got on the left-hand side there. We could also call this one-way replication. Means we never need to worry about the conflicts. Anything that happens on the primary will be pushed out the target. Anything that happens on the target will not be pushed back up to the primary. We also have one called an update anywhere scenario, where the one on the right hand side here. So what happens here, if you make a change on the LA system, that change will be pushed out to the Washington and New York system. Anything on New York will be pushed to the other two, subject to how you've defined your underpinning replication. One of the things we do need to worry about in that situation, though, is conflicts. So we'll touch a little bit on that later. The main thing, remember, although ER is highly configurable, you do want to try and make it nice, keep it as simple as you possibly can. The KISS rule really does help you out an awful lot here. ER doesn't directly support DDL, so if you create a table or you change a table, by default that will not be replicated. You could, so for example, a truncate command will not replicate out to the targets. We can get it to replicate using grid commands if you want to go down that route, but by default it doesn't replicate the actual DDL. So again, there's another image stolen from an older IBM presentation. This is coming back to what we're talking about, making it as complicated as you want it to be. We have the concept of root and non-root nodes. Non-root servers are defined to be servers that have a parent. So if you look at this one here, we've got Dallas is a root node and Lenexa Mobile is a non-root node. So they'll still have a copy of the global catalog, so the database that controls the entire system. So the parent node acts as a sync node. As with most systems, there's some prerequisites that we must configure prior to getting ER up and running. The first one is probably fairly obvious to you. We need to have the servers, they must be trusted to each other. So you need to be able to, for example, DB access to anywhere within the replication system without being requested for a password. You can achieve that by whatever method you want. I personally like to use the remote config setting and then store the file in Informix dir etc. That gives me control of it rather than the sysadmins if you want to use standard etc host equivalents, etc., etc. We have to configure some DB spaces, and we'll touch on that in a second. We need to configure the SQL hosts, and again, we'll touch on that in a second. And there's some table requirements. Table requirements, we really do need, well, we do need a primary key or unique index, and we might want to consider the use of shadow columns or shadow columns, ER key, CR calls, and REPL check. And again, we'll touch on them in a little bit in a while. There's a number of on-config variables that you might want to consider. These are the ones I would consider the important ones. CDR queue memory. CDR queue memory holds the queues of the data that's being pushed across the network. The default is 4 meg, I believe, although it might have changed. The recommendation is 30% of the logical log size. And unlike most systems, you can have too much CDR queue memory. If you just max it out, the system will definitely run slower. As we all know, the last thing you want to do is store anything in root DBS. So we have a variable CDR DB space. Sorry, I was next one down. CDR DB space. This is where your CDR database lives. The default's to root DBS, which we don't want it to do. So we would configure this prior to starting ER. We would configure the CDR DB space variable, and when we initialize CDR, it will create the database in whatever DB space we wanted. We cannot change the CDR DB space once the system is configured. We would need to rip everything down, change it, and rebuild it. The other ones we want to worry about is a CDRQ database SB space. Now, this is a smart blob space that actually contains the data that will be replicated. This one we can change on the fly. So if we decide that the DB spaces are getting too big or we got contention, we can add more of them if we want to. That doesn't require an outage. If it's not defined, the later versions of the engines will just create that space for you. If you're worrying about CDR or serial keys, we have a CDR serial, which gives you a ability to allow multiple tables to have serial keys inserted into them on different servers, and we'll guarantee that we don't get a conflict. The simplest example would be you've got two servers and you insert even numbers into server 1 and odd numbers into server 2. And again, CDR serial can be changed on the fly. It won't retrospectively move anything, but going forward, any new serial values will be inserted into it will be inserted correctly. You used to have a CDR header DB space. That's no longer needed. It's been deprecated. It's no longer in use. So if you're looking at an older system, you might see some DB spaces defined for header information. The idea back then was you'd put the headers in one space and the data in another. And I think with the testing they did, they found that there was no performance gain from doing that. So once we've got our DB spaces configured, and I think the only ones that is vital there that you really want to do is the CDR DB space, although I would recommend you set the other three as well. Now, ESQL hosts, if you have a dedicated ER network, so we want to send the traffic over different IPs or different ports or different network cards, then we can create a new set of Informix servers for the instance. So in the example here, we've got two instances across the top, Theoden and Gimli, and so two separate servers, they're running quite happily. And we have a dedicated different IP range replication network. So and these are the Theoden REPL, the Gimli REPL. And the way we have to do this, we create what we call a group. And this is this G_Theoden. That tells the system that we have a group of servers, or to treat it as a group. The syntax is fairly straightforward. The second line Theoden REPL is just a standard Informix SQL host line with two lines on the end, or one comment at the end, G_G Theoden. It tells us what group that's in. Most people would write these in a way that logically they're easy to read. You look at the line above there, we've got I = 1. Each server within the replication set must have a unique identifier, I, 1, 2, 3, 4. I tend to make them the same as the Informix servers. There is a limit. I think it is now 64K. I believe it used to be 32K. The E at the end is not necessary. It's not vital. It just tells the processing of the SQL hosts when to stop building up this group of Theoden. So if you are using other architectures or other servers, you might have Theoden might be 4 or 5 different servers, and you might you want to stop the processing of the file sooner. In most normal situations, I would suspect it doesn't save you an awful lot. So we've done the basics. We've configured onConfig, and we've got our SQL hosts up and working. We've done our DB access. So from Theoden, I can do a DB access connection to everything we see on the left-hand side. So on Theoden, I can do DB access sysmaster at G Theoden, Theoden REPL, G Gimli, and Gimli REPL, all without requesting a password. And on the same side, I can go on to Gimli and I can do the same DB access sysmaster to the other 4 servers. If that lot all is correct and all connects correctly, then we can move on to the next phase. And again, if you're doing this, I would strongly recommend you write some scripts to make this easier for you. A simple one, we've used just a simple script that does test connection, and it just runs through your SQL host file, making sure you can connect to everywhere you think you want to get to. So how do we actually define the CDR itself? Again, it's fairly straightforward. Now, we run a command called CDR define server, looking at the top line here. So this will define the master, for want of a better term. So this is CDR server. We're going to connect to Gimli REPL. We got a couple of options there we'll come back to briefly. And then we're going to initialize G_Gimli. So this will create the CDR database. It will populate the CDR database with all the relevant tables, etc., etc. The next line down, CDR define server. Again, we're connecting Theoden REPL. So we're connecting to the box now, and we're telling it to synchronize with G_Gimli. And then we're telling this server is to initialize Theoden. I was always advised that when you connect on the defined server, you want to connect on the actual server and not the group. Although it seems to be fairly common now, you can use a group as well. I've forgotten why back in the version 7 days, I was always told that's what you needed to do. Maybe you don't now. I don't know. That's just a habit I do. There's a lot of options on the CDR defined server line. We will touch on some of them in a while, but the two I think you will always want to connect are the A and the R directories. We have an ATS directory, which stands for Aborted Transaction Spool, and we have an RIS directory, which is Row Informix Spooling, or information spooling, I think. So if we have a transaction fails, it will write the header information, if you'd like, to the ATS directory, and every row that was impacted by that failure will be written to the RIS directory. And you can use various tools at a later date to come back and investigate what's gone wrong. The only real gotcha there is if you're using time series data and replication, the information is worthless because you can't really see what time series element was failing. Because it's an opaque type, you don't get the detail that you get on a row. You won't see the column data that's failed. And once you've defined it, you can do a CDR list server, and hopefully it'll all come back something nice and pretty like that. It tells you that your servers are connected, they're active, when they're connected, and when was the last change. That's all well and good. So we've now got the servers up and talking to each other, but absolutely nothing is replicating at the moment. We haven't told it how to replicate anything. So now what we need to do is define some replicants. So we've got two examples here. Looking at the top one first, we're going to do CDR define replicant -C. C stands for conflict, which we'll touch on a little bit, and is ignore. The scope we've got there, I think might be a bit missing. We're connecting to G Theoden. We're calling the replicant Theoden Oninit Nagios, and then we've got the select statements that we'll be using to actually generate the replicant. So we're going to be selecting star from Nagios at both ends. Come up with a naming convention for your replicants that makes sense to you. There's nothing worse than getting a replicant that fails or a replicant problem coming back and saying a replicant 22 failed, because it's absolutely meaningless. Version 14 now, I believe you can actually list the replicants by replicant ID. You don't have to. It used to tell you things like replicant 2584 had failed, and now you can do a list replicant 2584 and it'll come back and give you the actual information about it. So our scope there, we've got, we mentioned, so scope is defined to be either row or transaction. If the scope is defined as a transaction, then the entire transaction will not be applied if there's a problem with any part of that transaction. If the scope is defined as a row, we'll try and apply all the rows we possibly can within the transaction, even if a failure does occur. So you could get a transaction that spans 100 rows, and for whatever reason, one of them fails, but 99 will be applied. And if you've got transactional level scope, all 100 rows would be rolled back on the targets. Since ER uses defer constraint checking, the entire transaction will fail if there's a referential integrity issue, though. And then so down, another one a little bit lower down. So the top one is actually an update anywhere. So any changes we write into either Theoden or Gimli will be replicated across the other side. If you look at the lower one here, we are running a primary, a master slave primary setup. So if we apply any changes to customer on Theoden that meet the select requirement, where i.e. the customer is active, that will be pushed across to Gimli. If someone comes along and updates Gimli's customer, that will not replicate back up the system because we've got a one-way replication defined there. You also notice in the second one, we've got a -C. That's a relatively new option, or I think it is. That will force the replicant definition to create the table on the target. So in this situation here, if customer doesn't exist on Gimli, it will actually create the customer for you. It will use the same, I believe it uses the same DB space layout, etc., same index names and everything. So it is a DDL exact copy going across the system. So we've now got CDR up and running. We've got a replicant defined, and we're still not actually replicating anything. Okay, before we jump on that, let's just look at the conflicts. So the conflicts are, as it says, always, which basically means it will always apply. You really want to avoid that unless you're using a primary target application. The ignore, basically, just apply it no matter what. Timestamp, the row with the latest timestamp will win. This can cause you problems when you have a laggy network and you might have a timestamp or time delta between the servers. So it gets updated in one point, pushed to another server, and the other server hasn't caught up by the time it tries to push something back. So it can cause you some issues. When we do an insert, an update, we have the ability to convert an update statement into an insert statement if the row isn't there on the target. We can prevent that with using the delete wins, or delete wins will not allow an upsert operation. Coming back to TimeSeries is one of my little products I really like. You have to use always apply rule on TimeSeries data, and although TimeSeries is update anywhere, you have to make sure that when you apply at the application level, you got to make sure that it really is running in a primary slave type situation. Otherwise, you'll get some problems. That doesn't mean you can't push data from both ends. What it does mean is you can't be pushing data from both ends at the same time. Oh, sorry, I was wrong on the other side. It was a -U creates the tables if they don't exist. We have an ability to use a primary key, a index, or ER keys. Now, some of the indexes might be more efficient. So imagine you've got a large number of unique keys, and for whatever reason, you might decide that you want to access one of them more often than the others. So you can actually specify which columns can be used for the replicant key, replication key. It has to be an exact order match to how the index is defined. And the other one, by default, when you run a replicant and the data is inserted at the target, it will not fire the trigger. You can tell it to fire the trigger if you wanted to. So imagine you got a trigger that runs a piece of SPL that actually might do something at a file system level that is hard for you to duplicate. Without that trigger, you might want to fire the trigger at that point. So we've now got syscdr is up and running, so we've got connectivity, we've got some replicants defined, but we're still not actually replicating any data. We must start the replicant. That's fairly straightforward. CDR, start the replicant and the replicant name. Then you can do a CDR list and it will tell you what's been replicated. It'll tell you the various state of it and various information about it. The frequency is immediate. We also, one of the options when you're defining the replicant, you can tell it to replicate on a time basis. You can say, replicate every 5 hours or whatever you would like. And the data will be held until that point. Could be very useful if you're on a network where nobody uses dial-up now, but that sort of logic, maybe you're on a satellite link that isn't readily available. We're doing some work with some oil companies, and their rigs were out in the middle of the ocean, the middle of the Gulf of Mexico and the North Sea and places like that. And because of costs, they wanted to only replicate at certain hours of the day because of the way their satellite links were configured. We can see what the options are. We're running at full transaction. We're running at full row. Full row, is, as it suggests, is we will replicate every column within the table regardless of whether it's been altered or not. If you don't use full row, you'll only replicate the data that's actually changed, the columns that have changed. Okay, so we've now got the syscdr started, we've got connectivity, we've got a replicant, and we're actually replicating. We want to know, is that replicant actually in sync? So we can run a check repl command. And what we're saying here is run a check replicant on Theoden with a master of Theoden for the replicant Theoden DB audit customer stats. Then tell it, give it a job name at the end there. And what we'll see is an output something like what we've got below. On a really busy table that is active all the time, it's highly unlikely the larger tables and most active tables will ever be fully in sync when you actually run a check repl. There's always in-flight data. So all I know at the moment is I've got 1,453 rows missing. If this table is not being used at the moment, I know I've got a mismatch. If the table is active, very active, that just might be in-flight data. So we've got 1,453 rows missing. We want to make sure we get them back and synchronized. So we run a CDR check repl command again, but this time we have a -R option. We used to have a CDR repair. That option has been deprecated, and now, although it's still there, it'll disappear at some point. So when we run the CDR check repl with the -R option, it will scan the data and it will correct all the rows that are there. You can see there we had 1,453 missing. We processed 453. So if you remember there, we've got a name at the top, Theoden DB audit customer stats. When you're running a large sync job or repair job, check job, you want to be able to see how it's getting on. So we've got a CDR stats check. And we do CDR stats check the replicant name that we were looking at, and we've got a -R2, so it repeats every two seconds. I was chatting to Madison a long time ago, and he said the timing information here is completely irrelevant. It's completely made up, and don't trust it in the slightest. I don't think that's 100% fair. I think you take it with a grain of salt. When you're working on very large tables, there's a lot of rows. It might appear to hang. Give it time, it will work it out, and sometimes the timings, they jump all over the place. I've never found any real logic to it. So we now know how to get syscdr configured. We know how to define a replicant. We know how to start a replicant. We know how to check a replicant. That's all well and good, but we don't actually know how do we get the data from one end to the other. How do we do the initial synchronization? The obvious two, using an on-bar or an on-tape. So just take a backup from system A and back it up to system B, and then use a combination of sync commands and check commands just to make sure everything's up and accurate. If you're lucky enough to be able to take an outage, you can take the outage, back up your system, restore it to the other side, configure everything, bring everything up online, and you know it's accurate because no one's made any changes. We also have the ability, if you're working on an HR cluster of some description, HDR, RSS, you can run a CDR check sec to ER, and that will convert an HDR node or an RSS node to a ER node. And then, like before, you'd have to start it. One I didn't mention there, you could just run a CDR check REPL -R on every table, and that would bring the data across. That is surprisingly inefficient if the tables are virtually in sync and they're very large, but if the tables are very large and one of them is completely empty, it's a lot more efficient than you think it might be. So if you've got multiple million row tables and you know they're heavily out of sync, dropping the target and allowing CDR sync to push it across is not a completely bad idea. We've also got now a CDR migrate option. This is similar to anyone who's used the IFX clone in the past. It uses similar sort of theory. So we say CDR migrate server A to server B, and it will do all the heavy lifting for you. It will create the server, it will do the replicants, it switches tables to raw, it moves the data across, it pushes them back, it makes sure everything's in sync, it runs in parallel, all this sort of clever stuff. And it's definitely a tool you want to consider using. While we're here, CDR Migrate Server is available in version 14 and maybe the latter 12s. What people don't realize is CDR is just an application. So there is nothing stopping you from taking, subject to licensing, there's nothing stopping you taking a CDR binary from a version 14 engine and running it on a version 12 box. I know this works because we hit a bug in the CDR in a later version of 11.7, and our solution was to take the latest version 14 binary and run it completely CDR binary, and we ran the 14 binary in our 11.7 ER replication system where we had no version 14s in there, and it ran without a single problem. We did get the blessing of IBM, and it was their suggestion, but it does work. So you can actually do that. And that's about all there is to it. A few things I'd like to touch on. REPL sets. REPL sets are a way of grouping replicants together. I've never used them extensively myself because I've always had everything heavily scripted. But what you can do is define a set of replicants, as the name suggests, and then you do start replicant set, and every replicant that is inside there will be all started as a single command. We have the ability to use templates as well. Again, it's not something I've ever had to use a vast amount because everything I've done is heavily scripted, but a similar sort of idea. You define a template and you realize a template against a set of tables. I want to touch on table requirements. Tables must have a primary key, and depending on your version, you might be able to use a unique index. If you can't get any of those, you can use what we call an ER key. An ER key and REPL check keys are, an ER key is a fake primary key. It's a real primary key, but it's fake from our point of view. It's invisible to the application. REPL check is a column that you do want to use when you get onto larger tables. REPL check is a checksum from the row. It's built from the checksums of every column within the table for every row. And unless your table is really small, it's virtually guaranteed you want this column because it will make your checks and synchronization significantly faster. So you want to take whichever one of your indexes, one of your primary key index or primary indexes, and add a REPL check to end of that as an extra index column. And that will mean that when we want to do synchronization, we can do key-only scans. Some fairly typical gotchas. Don't just drop the syscdr database. If you've got CDR running, if you try and drop it, obviously it won't let you, but if you do a CDR stop, you can just drop syscdr. It's highly recommended. You don't want to do that. There are structures left in shared memory, an update anywhere model that could cause you some issues. This is a one from my dim and distant past. If there is a performance issue, blame the target. The problem is 99% of the time will be the target. There's something up with the target, so always blame the target. As an undocumented, if you run export mytrace equals 1, when you run the CDR commands, check REPL, sync REPL, it will show you the SQL that's actually been run at the time. Designate a master. By this, I mean, if you've got a system that's got 20 or 30 servers, get into the habit of running all your commands from one server. You can run a command on any of the servers by using the -C option on your CDR commands, but get into the habit of running everything from one place. I've been to a number of sites when they haven't followed that, and they find that you're doing things from all over the place and people get themselves in a complete and utter mess. And the designated master should be the Informix instance in the replication cluster that has the latest version of the software on it. CDR binary, like I said, is an application. It understands all the capabilities of the lower engines, but it won't understand the capabilities of the later engines. So if you've got an 11.7, 3 or 4 servers and a few 12s and a couple of 14s, and if you've been playing with 1DB, you've got some 1DBs in there. If you've got 1DB2, you want to be running syscdr, the CDR commands from the 1DB2 instance and not the other ones, because that's the latest version. Have lots and lots and lots and lots of log space. And if you have any doubt, add some more. When you can get into what we call a DDR block situation, where think of it as a checkpoint on steroids. It will hang the system until things catch up. There's really no way past that apart from having more log space, and the next one, avoiding very large transactions. ER was never designed to do very large transactions work, and that could get you into DDR block situations. Although you can run everything as CDR commands to find out what's going on, they are an application that connects to the database. OnStat is by far your friend here. Virtually everything you can get that you need to diagnose it can be accessed via an OnStat command. Remember, OnStat doesn't access the database in the truest sense of the word, i.e. it just goes into shared memory and sees what's going on. So syscdr command might hang, might fail, might just appear to take a long time, where the OnStat will generally get the information back to you a lot faster. Upgrades. We've all done it all the time. None of us read the migration guide. We've got a version 11.7 engine. We come along, we've got the latest 14 code. We drop it on the box. We swap the binaries out, and it all just starts, and we're all very, very happy because Informix is wonderful like that. You have to be careful, though, if you're using ER. There will be a script. There is a script if you can't be bothered to read the manual in Informix etc, and it'll be called something like conf.cdr.sh. Just run that without any arguments, and it'll tell you what you need to do, how to convert your syscdr database. If you're lucky in a situation where you can just drop and rebuild, fine, just drop and rebuild it. But if you can't drop and rebuild for whatever reason, you've got to make sure you convert the syscdr database correctly. And the last one I just want to touch on is the ER and REPL checks. They're slow alters, and they're table level rewrites. Not only are they incredibly slow, they are very intense when it comes to log space. They're very intense when it comes to target space. So you readily need double the amount of space. So those can get you into a lot of problems. So what we're going to do now is briefly, before we call it a day, look at a couple of neat tricks. So adding these columns, like I said, is a slow alter. They can take forever. You will get table level locking. So you need an exclusive lock on the table. You can get LTXs. Now, you want to try adding REPL check to a 5 billion row table, that is a very wide table already. It will take forever. And I would argue you will not get that going to complete, because you just will not get the outage, you won't have the space, etc, etc. So what we want to do these as an IPA, which you can't do. Well, that's not 100% true. You can. One thing before we just move on to that, double check your tables aren't near a 16 meg partition limit when you start looking at ER keys and REPL check, because if they are, you'll get, we've all been there, you'll get halfway through the thing, then it will abort because we've hit the table out of space, and it'll roll back. So how do we trick the system with the ER key? Well, all we have to do is add to the table the 3 columns that ER uses, and this is what they're called. They're called IFX underscore ER key 1, 2, and 3, an integer, and a small int. Now this is now an IPA, so we can just run that, and within reason, that will be instant. That obviously is not giving us a primary key. So now we have to populate. This is pseudocode, fake code, call it what you will. This is fundamentally store procedure. So what this store procedure will do is fake what happens inside the engine. When you run a add ER key, it will add 3 columns, and then it will populate these 3 tables as per what we're seeing there. And basically, it's just a set of keys, and it just guarantees a uniqueness. So what we've done, we've added the 3 columns, we've populated them. We know from the logic, we can see there that they're all unique. Now we got to do the magic. So what we're going to do now, we will need an exclusive lock on the table. Okay, we want to lock the table. We want to create that index. I would say we want to create, we could do it as an online index, but I've tended to do it like this. At this point, because it's a large table, we're going to then fragment the index by expression across X number, probably 7 here, dB spaces, 8 dB spaces. And then we are going to add the primary key. So now we've got 3 columns are there. We've got the index that the engine would build for us. We've got the 3 columns populated the engine would do for us. And now all we have to do is tell the engine that those 3 columns are the right call attributes. So all we have to do is come along and alter those column attributes, 17, 33, and 65. And then those 3 keys now will disappear off your DB schema. But when you do a DB schema minus SS, the table will say with ER keys. So we've gone from what could be a multiple day outage to maybe a couple of hours to actually populate the table, etc., etc. We're not taking that huge hit that we were before. So we put that through as a slow alter, as an IPA, sorry. We can do the same with REPL check. REPL check's even easier. We alter the table, we put a big int on it, we update it to 9. We don't even need to have to populate REPL check, because REPL check is just the checksum on the row. When you update the row, the REPL check key will be generated. Okay, if you've got a synchronization issue, then it would have to be regenerated both ends, but you generally don't have that. So there's no need to populate it. There is a need to populate the ER keys. If you do want to populate it, you can use the internal function or the publish function IFX checksum. And what you do, you call IFX checksum on column 1, and at the second variable, it's a recursive call all the way down to the end and calling on every column. You will get casting errors on certain data types, Boolean being one of them, but if you use Booleans, you deserve everything you get, and you might have to do some casting. IFX check, I don't know if it's actually documented yet. A quote from Madison from a long time ago, he says, well, it's not documented because he was too lazy to document it. The IFX checksum is not exactly the same code that is used within the engine, but it gives you the same logic. Like I said, if you run an IFX checksum on a Boolean, it will give you an error. There's a couple of other things in there. So it uses the same logic, it doesn't use the same function, but you can use it. And the other thing, if you're running an IFX checksum on a table that has, say, 50 or 60 columns, and most of those columns are static, you do not need to have a checksum on the columns that you know aren't changing. And there's an option when you do a CDR check to check and sync to actually specify your own checksum routine. So you could come up with your own checksum routine that only looks at the columns that you know are changing. The ones that are static, you don't need to worry about. So that's really all I have to say. Now, ER is a complicated beast. It's not a scary beast. You will never get to learn it within a 1 hour presentation. It is a multi-day course if you want to take one, but it's a very, very powerful tool. So I'm going to hand it over to questions. If anyone has any questions after this, either on the live call or on the replay, my contact details are down there at the bottom. Yeah, I'm based in the US, so I appreciate if you do call me, bear in mind of the time zone element, but I'm always happy for people to give me a call if they've got a problem. And that's basically all I have to say. So I'll hand it over to questions.